For the past 10 years, I've been using Docker for pretty much anything related to application deployments. Whether it's packaging my applications and its dependencies, integrating with CI/CD, or just straight up deploying my applications to a Kubernetes cluster. Most recently, I've been using Docker to deploy to a VPS, in what I would consider a production-ready way, allowing me to have full-featured deployments without the need to use a platform as a service, such as for Cell, Netlify, or Railway.com. Despite this, however, late one night when staring at my terminal, I received this warning on macOS, letting me know that the Docker app was going to be deleted. And so I started to wonder, what would happen if I didn't have Docker? Would I still be able to deploy to a VPS in a production-ready way? Therefore, due to an unquenchable thirst for knowledge, I decided to give myself a challenge. One, to see how difficult it would be to deploy to a VPS without the use of Docker or any containerization. And as it turns out, it's not only easier than I thought, but it was also a lot more fun. Before I began writing any code, I first decided to list out some requirements in order to define the challenge. The main goal that I wanted to achieve from this challenge was to have a full application deployed on a VPS, in what I would consider a production-ready way. This meant, rather than just copying over the binary onto the machine, executing it and saying "job done," I wanted to make sure that the deployment met a number of different requirements. The first of these is that my application would be deployed in a robust way, meaning that it would automatically be restarted if it happened to crash, or if the server itself was rebooted. In addition to this, I also wanted to make sure that my application would be deployed securely. This meant taking measures to both secure the VPS from potential attacks, whilst protecting it from my own application by restricting its privileges. I also wanted to ensure that any secrets my application required would be stored on the machine in a secure way. Additionally, the server would also have to have HTTPS enabled, and would be configured to automatically renew certificates when they expired. After defining my security requirements, I then moved on to some more advanced production-ready features, starting with automated deployments, meaning whenever I pushed a change to the GitHub repo where my code lived, the server would automatically redeploy those changes within a few minutes, provided there were no issues. Which actually brought me on to my next requirement, setting up zero downtime deploys. Meaning that when the application did redeploy automatically, it did so in a way that didn't cause any downtime. This led me on to my final requirement on this list, which was to ensure I had automatic rollbacks in case something went wrong. With my requirements defined, I then went about setting any other constraints I had for the challenge. The first constraint that I set was that I wanted to achieve this using open source software, rather than anything proprietary. Additionally, I also wanted to make sure that I prioritized using system tooling, provided on the actual VPS, rather than adding in any third-party abstractions unless it was absolutely necessary. Additionally, I decided I was only going to use either bash or manual process in order to achieve this deployment, rather than relying on any automation tools, such as Terraform, Pulumi, or Ansible. The reason for this is that I wanted to gain a better understanding of system administration, instead of, say, learning how to set up a VPS the Terraform way. With my requirements and constraints defined, the next thing to do was to build an application to deploy. So I decided to spend a snowy morning building one from scratch, and came up with Zenbin, which is a Go application that you can post snippets to that would last for around 7 days, allowing you to share them with any of your friends, provided you have any that care about snippets. And I don't mean your boy Chatty G, who, let's face it, isn't actually your friend. In any case, with the challenge now defined, I adjusted my desk so that I could take an action stance, and went and grabbed my first task from the Kanban board, which was to obtain a VPS in order to deploy to. Fortunately, that's where the sponsor of today's video comes in, Hostinger, who have kindly provided me with yet another VPS instance to use throughout this video. If you're looking to obtain your own VPS instance, then Hostinger is a great choice. In my case, I have a Type KVM2 instance, which provides 2 vCPUs and a whopping 8 gigs of RAM. The KVM2 also comes with 100 gigabytes of SSD storage, and a massive 8 terabytes of monthly bandwidth, which is more than enough for you to host your own course platform. Look out for that in Q1 of this year. Not only is this instance incredibly spec'd out, but because Hostinger are running a New Year's sale, it's also available at the incredibly low price of $5.99 a month when you sign up for a 24-month term. All of this means it's the perfect opportunity to bag yourself a low-cost VPS, which is pretty great if you're planning on learning how to deploy your applications to one. And that's not all, because if you happen to use my coupon code DREAMSOFCODE when checking out your brand new VPS, you'll also get an additional 10% discount on the already low price. Therefore, in order to pick up your own VPS instance at an affordable cost, go ahead and visit hostinger.com/dreamsofcode, or click the link in the description down below. A big thank you to Hostinger for sponsoring this video. With my VPS instance in hand, it was now time to begin setting it up. For the operating system, I decided to go with Ubuntu 24.04, which in my experience typically tends to be the most popular operating system when it comes to spinning up a VPS instance. Once I had selected my operating system, the next thing to do was to set a secure password for my root user, as well as copying over any SSH public keys I wanted to use. Once I had done so, my instance then began deploying, at which point I decided it would be a good time to set up a DNS record pointing to it. Because I didn't have any spare domain names lying around, I decided to go ahead and purchase the zenbin.xyz domain name from Hostinger for the low cost of $1.99 for the first year. Once the domain was registered, I then went about adding an A record and a quad A record for those who love IPv6, pointing it to the relevant IP address of my VPS. Once both the DNS record had propagated and my VPS was deployed, I was able to SSH in. With my VPS now accessible, the next task that I had on my makeshift Kanban board was to ensure that my VPS was secure. To achieve this, I went through the same steps that I normally would, adding in a new user by using the add user command, and copying my SSH key to them using SSH copy ID. Afterwards, I went about setting up sudo permissions for this user by using the usermod command, passing in the -ag flag, adding this user to the sudoers group. Then I checked that everything was working by first SSHing in and running the following command in order to test the sudo permissions. With my user now set up correctly, I then quickly took a look at my auth.log and noticed I was already being spammed. So I went about adding in some network security onto the VPS, beginning with setting up the UFW firewall, which I did by first allowing the OpenSSH app and then enabling UFW using the following command. Next, it was then time to harden SSH, which involved both disabling password authentication and root access from the SSHD config. Then, once those changes were made, I restarted the service and made sure that I couldn't SSH in as my root user. Next, I then decided to further harden SSH in order to prevent script kiddies or DDoS attempts. Typically, I would achieve this using fail to ban. However, a good number of my audience had recommended I try Crowdsec, which happens to be similar to fail to ban, but is also written in Go. Therefore, I felt like this would be the perfect time and decided to give it a go. So I headed on over to the Crowdsec GitHub repo, copied the installation commands, and pasted it into my VPS terminal. Unfortunately, however, I actually ran into a bit of an issue, where the install command was hanging at one of the install steps. Fortunately, this wasn't anything that a well-placed Control-C couldn't solve, and the installation continued without any further hitch. Once it was complete, the Crowdsec service was now up and running, and so I decided to take a quick look at the logs, which informed me that there was already a bad apple attempting to brute force in. Fortunately, Crowdsec told me that it was blocking them. However, when I went and checked the auth.log, I could still see events coming in. This is because I hadn't actually installed a firewall, or a bouncer as it's called in Crowdsec, which is needed in order to block the IP. So I went about doing so, choosing to install the Crowdsec Firewall Bouncer IP tables version. Once it was installed, it then proved much more effective, and the IP of the bad apple was now temporarily banned. With that, my VPS was now reasonably secure, and it was time to move on to deploying my application. Instead of doing so using my main user, I actually decided to create yet another user for the actual deployments called deploy. This would allow me to restrict the permissions of this user even further, such as not allowing them access to sudo. This was actually a good indication that there were some benefits of using this deployment model compared to using Docker, as I was better able to control root access compared to using the Docker daemon. In any case, with my deploy user created, I then needed to copy over my SSH authorized keys in order to be able to SSH in as the deploy user. This was needed because I had already disabled password authentication when it came to SSH, which meant I couldn't just use the SSH copy ID command for any user that didn't already have an SSH key set up. In any case, with my new deploy user configured, the next thing to do was to decide on how to get my application installed onto the VPS. The first idea that I had was to just clone down the GitHub repo for the project and build the application directly on the box. However, in my experience, this is generally considered a bit of a bad practice. Not only is it not great to have your source code sitting on the machine, but whenever you trigger a redeploy, it's going to consume resources in order to actually build your application, which takes away from serving your users. Therefore, I instead decided that a much better approach would be to build my application binary outside of the VPS, and then copy it over in some way. So in order to get my application up and running on the VPS, I did just that, building it on my local machine using the following commands before copying it over using SCP. Then, once the binary was available on my VPS, I switched back to it and ran the following command to execute it, which unfortunately didn't actually work. This is because the binary being built was dynamically linked, and because I was building on NixOS, it wasn't properly linking on the actual server. Therefore, I needed to produce another binary that didn't have cgo enabled, which I did using the following environment variable. Once it was built, I again copied it over using SCP, and this time, the binary was able to be executed, although it wasn't exactly working as my code was now panicking. This panic was occurring because I hadn't set the Redis URL environment variable, which is what my application was using in order to store the snippet data. This also meant that I needed a Redis instance, or at least one of its forks, available for my application to connect to. Therefore, remembering my original open source constraints, I went ahead and installed the Valkey server using the following apt command, which initially I accidentally did on my deploy user, who didn't have sudo permissions. Once I realized my mistake, I exited out and returned to my main user, where I ran the same command again, although this time successfully. Once the Valkey server had been installed, I then went about and opened up the Valkey configuration file in order to make a couple of desired changes. The first of which was I wanted to set a max memory limit of the Valkey instance to 6 GB, given that my instance had a nice large 8 to work with. Setting the Valkey configuration this way would mean that I would always have at least 2 GB of RAM available for my system and application to work with, which was going to be more than enough, but I wanted to make sure that Valkey wouldn't starve any of the other processes. In any case, the next thing I needed to do was to add a max memory policy, which I set to the volatile/TTL option. This policy meant that if the max memory limit was reached, Valkey would start removing keys with a TTL set, with the keys with the shortest remaining time to live being removed first. Next, I then made a configuration change to write data to the append-only file, which meant that any data stored in Valkey would be persisted, in the event that either Valkey or the actual VPS instance was restarted. Lastly, I then went about adding authentication in order to connect to the Valkey instance. As it was just me using the machine, I decided to not set up an ACL, although this is the recommended practice. Instead, however, I just decided to enable the require pass option, and changed it from the default password to something a little more secure. With the configuration changes made, I could then go about restarting the Valkey service, and it was ready to go. All I needed to do now was set the Redis environment variable, which I did with the following export command. Then I was able to execute my application, and this time it was up and running. In order to test that it was working, I went ahead and added in a rule to allow port 3000 on the UFW firewall, before then opening up a web browser and navigating on over to zenbin.xyz at port 3000, as well as checking the logs to make sure I was actually hitting my service. With that, my application was now up and running, but it certainly wasn't what I would consider deployed. For starters, if the application happened to crash, or, networking gods forbid, the VPS was rebooted, then I would be forced to SSH in order to restart my application. This is no way to live, in my opinion. Therefore, I needed to go about adding in automatic restarts, which meant I needed to set up my application as a systemd service. To do so, I went about creating a new systemd unit file inside of my project's repo, setting it up to execute a binary inside of my deployment user's home folder. Rather than keeping the binary inside the root directory of my user's home folder, I decided to be a little more organized and keep it inside of a directory named production, just in case I ever wanted to have multiple environments. So I went ahead and created this directory before copying the Zenbin binary into it. Once that was complete, I then went about adding in the remainder of the systemd unit file, asking for some best practices from ChattyG, which ended up not working. I told you can never consider that guy a friend. In any case, some of the key security measures that I put in place were to ensure that the application was only going to be ran by my deploy user, as well as restricting access to the file system. Additionally, I also added in options to ensure that the application would restart on failure, and made sure to also set up an environment variable in order to configure the port. Afterwards, I then went ahead and pointed standard out and standard error to the journal control commands, which would make it easier in order to debug later on. Next up, I then went ahead and added in an environment variable for the Redis URL we had already looked at before. However, you may notice that I omitted the actual password of the Valkey instance inside of this environment variable, as I was going to commit this file to my GitHub repo. Whilst I was considering Valkey, I also went ahead and added in some dependencies on the Valkey service, defining it as a requirement of the Zenbin service. With that, my systemd unit file was now ready to go, so I went about adding it to my Git repo before downloading it onto my VPS using the following curl command. Before I went ahead and added it into systemd, however, I first needed to make a quick change, which was to add in my configured password for the Valkey instance into the Redis URL environment variable, which, of course, I had purposefully omitted from being committed into my code. With that, the systemd unit file was now ready to go, so I copied it over to /etc/systemd/system before then reloading systemd and enabling my Zenbin service. Upon doing so, I then checked that everything looked good using the system control status command. This gave me the big green go, letting me know that everything was working, so I opened up a web browser and checked that the service was available, which it was. With that, my application's deployment was now complete. The next task I had on my backlog was to ensure that my secrets were now secure, as currently they weren't. If I went ahead and used the following system control cat command, which you'll notice doesn't use sudo, I was able to pull out the Redis connection URL as the deploy user, which contained my super secure password. Therefore, as the responsible developer that I am, I wanted to make sure that this password couldn't be accessed by anyone who didn't have sudo permissions. To achieve this, I decided to create an environment file, storing it under the /etc/env directory. Inside of this file, I went ahead and added the Redis URL as follows. Then, in order to use it with my actual service, I added in a new environment file option, pointing it at the /etc/env/zenbin.env file I had just created, and removed the existing Redis URL environment option I had already previously defined. Once that was complete, I then needed to make sure that the deploy user couldn't access this new file, which they currently could. So I went ahead and changed the permissions from 644 to 600. Which meant only the file's owner would be able to read this file, which I then confirmed. Lastly, all that remained was to reload my systemd configuration and restart my Zenbin service, which I confirmed was working correctly, whilst also ensuring that the Redis URL was no longer being exposed. In hindsight, I'm not too sure how secure this approach is, given that the secret is still available in the application's environment. Instead, using a secret manager is going to be more effective. In any case, now that I had secrets somewhat secure, I was able to move the task into the done column, before picking up the next one, which was setting up HTTPS. Typically in the past, I would normally achieve this using Nginx as a reverse proxy, with certbot set up in order to handle certificates. However, a good number of people in my audience have been asking me to check out another application called Caddy. So I decided to give it a go and went about installing it. To do so, I copied in the following commands from the Caddy documentation, which not only installed the Caddy application for me, but also went about setting up a service file. However, when I opened up a new terminal window and sent a curl request to the zenbin.xyz domain, it was just hanging. This was happening because UFW was still blocking port 80 and 443, so I went ahead and added them to the allow list. Afterwards, I then confirmed that Caddy was working, which meant I could now configure it. In order to do so, I needed to edit the Caddy file, which contained the current configuration. I managed to locate this by using the system control status command, which showed me it was currently available under /etc/caddy/caddy file. Therefore, I went about opening this up inside of my text editor, and read the very helpful documentation located at the top of the file. This documentation told me to replace the reference to port 80 with my hostname, and everything should work as expected. So I went about doing so. Additionally, I also went about commenting out the default configuration for the actual host, and configured it to reverse proxy to my local host 3000, which was the port my Zenbin service was listening on. With the changes made, I went ahead and saved the Caddy file and reloaded the service. And within about 1 minute, I had HTTPS up and running. Well played, Caddy, you now have a new fan. In any case, once I had HTTP set up, the next task on my list was to begin adding in automated deployments. In my mind, I knew how I wanted to achieve this. The idea was to basically obtain a copy of the new binary, copy it over to the correct location, and restart the service using system control restart. However, whilst the basic idea was pretty simple, the actual implementation was a lot more difficult. Typically, when using a Docker-based approach, I would just upload the Docker image to a Docker registry, tagged with the git commit hash of the code that the container was built from. In this case, I wanted to do something similar, but I wasn't sure of the correct approach to take. The first idea I had was to make use of the GitHub release feature, which allows you to store binaries associated with a given git tag. Initially, I thought this was going to be the perfect approach. However, upon investigating, I realized I would need to actually add a git tag for every commit, which felt like a grand misuse of the feature. Not only this, but I also feel like GitHub releases are more geared towards semantic versioning, rather than using it for continuous delivery. Therefore, I decided to look at a second option, which was to set up an S3 bucket where I could upload my individual binaries on, inside of a directory related to the git commit hash. Then all I would need to do would be to set up some AWS credentials on my VPS. Then I could easily just download the binary using the AWS CLI. To me, this felt like a decent approach, as I could use the bucket as a sort of artifact repo, supporting multiple operating systems and architectures. And I could even set up other automation based on AWS S3 events. The main reservation that I had was that this was going to be adding additional infrastructure into this challenge, which was something I was trying to avoid, as it would open the door for me to use other services, such as Cloudflare. Therefore, I decided against taking this approach, and instead focused on a more VPS-based solution. This approach was much more simple, which was to use SSH and SCP to copy over the binary over to the VPS, with a file name consisting of the git commit hash. Then I could easily just run a deploy script to copy over this binary into the production directory, restarting the systemd service in order to apply the new release. Whilst this wasn't my favorite approach, it did work, and it also met my criteria. So I went about implementing it, and began by setting up a new SSH key for my deploy user that I could use with GitHub Actions. I created this key using the SSH keygen tool and copied it over using the SSH copy ID command. I then verified that I could log in using this new SSH key, before then adding the private key as a secret inside of GitHub. With my secret added, I then went about modifying my existing GitHub workflow in order to add a deploy step, which involved building a binary that contained the git commit hash, as well as setting the correct environment variables in order to build without cgo, as well as ensuring that the binary was built for the correct operating system, Linux, and correct architecture, AMD 64. After the build step changes were made, I then added in another step called deploy, which would use the SSH private key in order to copy over the binary using SCP. Next, I then went about writing a deployment script, which took the git commit hash as an argument and would promote the binary by copying it over to the production directory in the deploy user's home folder. Initially, I was achieving this by using the cp command. However, later on, I realized that using symbolic links was going to be more versatile, with the added benefit of not wasting any disk space. So I went ahead and changed my script to use symbolic links instead. This also came in handy later on when I went to implement rollbacks. In any case, once the binary had been promoted to production, I could then restart the service using the sudo system control restart command. Unfortunately, however, this did mean that the deploy user needed some sort of sudo permissions. However, there is a way to provide this without providing full root access. To set this up, I SSH'd in as my main user and ran the vi-sudo command in order to edit the sudoers file. Then I went ahead and added in an entry for the deploy user. However, rather than allowing them to have sudo on every command, I instead constrained this to the system control restart zenbin service command. Additionally, I set it up so that no password entry would be required. Once these changes were made, I then logged in as my deploy user and tested that sudo would work for system control restart zenbin.service, but wasn't available for anything else. Once confirmed, I headed back on over to my text editor and added in another command into the deploy step of my GitHub CI/CD action. This command will execute the deploy script on the server using SSH, preventing me from needing to copy it onto the actual machine. The benefit of this approach was that the deploy.sh script inside of the repository would always be the source of truth, and would help to prevent any race conditions from two workflows running at the same time, although there is a better way to solve this. In any case, with my script and workflow defined, I went about committing it to the GitHub repository and pushed it to my remote repo. Then I headed on over to the pipeline in my browser and watched to see if it succeeded, which at first it didn't. This was because I had forgotten to pass in the git commit hash as the argument to my deploy script. However, whilst debugging, I did confirm that the binary was being copied over to the actual VPS, so things were looking pretty good. So I went ahead and made sure that I was passing in the git commit hash as an argument and reran the pipeline yet again. This time, it looked like everything had succeeded. So to really test it, I went ahead and made a couple of changes to my actual application and pushed them up to confirm if my automated deployments were working, which not only showed me that it was, but it was doing so in a short amount of time, taking less than a minute from when I pushed my code up to the changes being deployed. This is in stark contrast to whenever I built systems using Docker, which in my experience usually takes more around 5 to 10 minutes in order for an automated deployment to go through. In any case, now that I had continuous deployments set up, I took this as an opportunity to add a couple more changes to my actual web application before moving on to my next task, adding in rolling releases. This task actually had a subtask that I would first need to complete, which was to set up replication for my service. Initially, I thought that this was going to be somewhat uncomfortable, especially when compared to using something like Docker or Kubernetes, where all you have to do is pass in a flag or a configuration option. Initially, when it came to systemd, I thought I was going to have to copy the service file another 2 times, changing the port value inside, which to me felt like a very unscalable solution, especially if I ever needed to make changes to all 3 services at once. Fortunately, however, after a bit of research, I came across the symbol, which allows you to deploy multiple instances of your service when it comes to systemd. By adding the symbol to the service file's name, it allows you to specify a name for that instance, which you can then reference inside of the systemd unit file. Therefore, I went ahead and copied over the existing zenbin service into a new service file that made use of the symbol, using the instance name as the port value for my service to listen on. Then I tested that this worked by enabling a version with the identifier of 3001, which will also set the service's port to be 3001 as well. Then I added the port to my firewall list, followed by ensuring that it was accessible, which it was. Therefore, I went ahead and disabled my existing zenbin service and enabled 2 more. One for port 3000 and another for port 3002. Then, in order to make sure that requests would be routed to each of these 3 instances, I modified my caddy file, adding in the 2 new instances to the reverse proxy configuration. Once the caddy changes were made, I then decided to make sure that everything was working, which I did by tailing the logs for each of the 3 services using the following journal control command, before sending up some HTTP requests using curl to confirm that each service was being routed to. With the load balancing confirmed as working, I went ahead and made the following changes to the deployment script, ensuring that each of the 3 instances would be restarted whenever a deployment took place. Additionally, I also needed to make the following change to the sudoers file in order to allow the deploy user to restart each service. Again, once everything was complete, I committed and pushed the new changes and watched the deployment pipeline to make sure that it worked successfully. With that, now that I had replication set up, I was ready to begin implementing rolling releases. To achieve this, I headed back on over to my deployment script and added in the following changes. First, keeping a reference of the current binary that these services were using. I achieved this by using the readLink command, which would give me the file name that the symbolic link was pointing to. Then, once I had a reference to the previous binary, I went ahead and added in a rollback function, which would re-promote the existing binary in case the deployment failed. Then, with my rollback function defined, I created a restart function, which could be used to restart the instances one by one. This function accepted a port number and restarted the associated instance, checking to see if the restart was successful. Then, if it was, it would sleep a number of seconds before checking the status of the service using the system control is active command. If the service wasn't running at any of these 2 points, then the rollback function would be called, and the script would exit with a non-zero code. With the changes made to the deployment script, I went ahead and committed this and pushed this up yet again. Then, in order to test that everything was working, I went ahead and made a breaking change to my code, changing the value of the Redis URL environment variable, which should cause my application to panic when it starts up. With the change made, I went ahead and pushed it up, which did cause my deployment to fail, and I could see that the script had attempted to roll back. However, unfortunately, it hadn't actually worked. After a little bit of debugging and a couple of iterations of the script, I ended up getting it working by adding in a load-bearing sleep, in between rolling back the symbolic link for the binary and restarting the failed service. Additionally, I also made a couple of changes to the caddy file in order to better handle when a backend wasn't available. This involved adding in a health check, which required me to also add in a health endpoint to my actual application. With all of the changes made, which you can actually view on GitHub if you're interested, I confirmed that the rollback was now working, which meant I had successfully managed to complete all of my production-ready tasks, all without the use of Docker or containerization. All in all, I actually had a lot of fun, and I felt like I learned some more about systemd and the other tools that I picked up, such as Caddy and Crowdsec. Whilst setting up a VPS this way is certainly more difficult than using Docker, it was actually a lot easier than I originally thought, and only really took me a couple of hours to get everything set up. In any case, as with all things, there are a couple of improvements that I would like to make in the future. These include using the Caddy API instead of a Caddy file, which I think could make it much easier to configure Caddy through the use of CI/CD. Additionally, if this ever became my more default deployment method, I would definitely need to add in some automation through either Terraform, Pulumi, or Ansible. Although that's something I'm definitely planning on taking a look at in another video later on this year. As for the actual challenge itself, like I said, I had a lot of fun, and would definitely recommend it to anyone who wants to develop their own skills. If you do decide to take on this challenge, then you can get yourself a low-cost VPS from the video's sponsor, Hostinger. Make sure to use the link of hostinger.com/dreamsofcode and my coupon code to get that additional discount. Otherwise, I want to give a big thank you for watching, and I'll see you on the next one.